Kyle mentioned, my name is Mark Parsons. Up until recently, I spent the past 15 years working in the civilian government as a dirty contractor. Most of it doing anything from help desk to incident response, network engineering, you name it. Over the past 15 years, I probably did it. Now I'm currently a developer and a threat analyst for a startup here in the Northern Virginia area. I'm also a father of 3 lovely kids who monopolize most of my time. Before I continue, I want to ask, is anyone here a fan of Archer? Okay. So the reason I ask that is the lead animator from Archer, his name is also Mark Parsons. Okay, kind of cool. Well, except that it's not, because he likes to do fan fiction videos for One Direction. Look it up. I swear it's not me. And if you want to be added to his videos, I cannot help you. I unfortunately get several emails directed towards him, but they come to my Gmail account. And a lot of people really want to be in his videos. So with that, before I get into the TLS hunting method, I want to do a quick review of some traditional methods, what I would call of infrastructure hunting or pivoting. Use whatever term you want to call it, research, whatever, for looking for network-related resources. We've already heard a couple of people mention today about passive DNS, and I want to echo what the Splunk guy said earlier. Your internal data is the best data to start with, and then use some of these external entities that I've highlighted below to help enrich your data. Beyond that, I also think that you should use Whois tracking. Most analysts probably already do this, but it's the idea of using domain registrant information to look for other potentially related domains or infrastructure. I've had some interesting use cases beyond just the registrant name or the registrant email. I worked a case back in 2012 where we had a malicious domain that was, the city it was registered in is a city that does not exist anywhere. And we pivoted on just that city and found 5 other related domains. Those were the only domains that were registered to that city, and all 5 had overlapping network infrastructure. So I'll list here a couple of resources that you can use to help you with this. Domain Tools is obviously the granddaddy of all that. They have a booth outside. If you're not using them, I highly suggest you take a look at them. Whoisology is a pretty new company. I would also highly encourage, if you're not using RiskIQ or PASSIVETOTAL, to give them a try. And if you really have no budget, like a lot of us here, try out Domain Big Data. It's completely free. It doesn't give you a lot of historical context, but it's a great place to start. So I've talked about passive DNS, I've talked about Whois, but what other data at a network layer or network infrastructure is out there that could help us with trying to track some more infrastructure? Well, it's TLS certificate. So before we start, I want to make one quick caveat. A code signing certificate is not equal to a TLS certificate. And the reason I say that is when you start to do this, you will certainly have reversers you work with or other analysts who will say, hey, I have this SHA-1 fingerprint of this certificate. Can you look it up? Do you see any network-related infrastructure? And you'll spend 15, 20 minutes looking for it, and you won't find anything. Like, well, can you give me more of the certificate? Can you show me what it's about? And they're like, oh yeah, we saw it on this binary. And a code signing certificate is to ensure that a binary is actually legitimate and it came from a particular vendor. Yes, I know these certs can be stolen, and there are ways to track it using rounding strings method. You can definitely write YARA signatures to find stolen binary certificates, or code signing certificates, excuse me. But I'm talking about, oh, come on, TLS certificates. TLS certificate is to ensure network communications between 2 hosts. It's not to authenticate the ability of a binary. It's to ensure, hey, this host that I'm talking to over a network is legit and the method is encrypted. So, the basics. For me, it boils down to 2 questions. An IP to a certificate and a certificate to an IP. So, real simple. What certificates have ever been seen on this IP address? Or, what IP addresses has that SHA-1 fingerprint been seen on? I'm going to be covering this one later. Let's just say it's been about 30. So some basic things to consider once you start using just those 2 generic questions. The first one is, do you have any malware that is using this TLS certificate? Meaning, have you seen something, a malicious binary running, it creates a network connection. That network connection creates a TLS connection, and you actually see that handshake. If you do, then it gives you a little bit more confidence that that's a certificate that you want to monitor, or at least look for. In some cases, I've worked with some reversers that they've actually seen references to the TLS certificate in the binary itself. That's the case, even more data for you to say, yeah, this is something I want to track down. The other one is how many other IP addresses, once you start digging, have been seen using that certificate. And the reason I say that is you'll come across some certificates when you start looking at it. You'll see, oh, hey, you got 200, 300 IPs. Then you realize that's the default certificate for an Ubuntu distribution, and it's on half the internet. It will happen, trust me. I run across this probably once a month on multiple different certificates. I'm not going to say don't rule out something that's got a couple hundred. I have a couple use cases for some nation-state groups that have been active since around 2012 using a particular TLS certificate that I now have them up to over 300 IPs over the past 5 years. So don't rule it out, but keep that in mind. The next one is the time frame. So the first one is, what time frame was the certificate actually seen on a suspect IP address? Was it seen around the same time that you saw malicious activity or saw malicious activity reported? Meaning, if you're looking at an IP that you saw TLS connection for last week, or just an interesting connection last week, was there a TLS certificate seen on it around the same time? Or was it from 2 years ago? You're not going to want to waste your time looking at stale data. The other one is start to look at the actual dates of a certificate. And the reason I say that is the not before is almost like a benchmark of where you could start of when that certificate should have been first seen. The way certificates work, when you create that certificate, that actual timestamp of when it was created shows up as the not before date. So if you're looking at a certificate and it says, hey, this not before is January 21st, 2017, you know that you will not see that certificate anywhere else before that. So that helps you kind of give you a time frame of where to look for the activity. And then the not after just kind of gives you an idea of, hey, was this certificate created for just a 1-year purpose, 10-year? And in some cases, I've seen up to 100 years, which is just interesting. And we can also kind of use the not before and the not after. Sometimes there's some similarities in different groups that will always create a certificate that's always of the same length. The other big consideration I would say is look at the issuer. The reason I say that is a self-signed. Self-signed is, I would probably say 99.9% of the time, only going to be seen in malware. You're not going to see it in a credential harvesting campaign or a campaign where they really want to get into your network, because you're not going to actually be a website that you're going to visit, because everyone's browser now freaks out about the self-signed and makes the user go through multiple steps to say, yes, this is legitimate. And it should raise enough of a concern now that users wouldn't go to it. But go to the free certificates. Look at things like Let's Encrypt, Whois, well, hopefully Whois, since it's being pulled out of most of the CAs now, or the root CAs in the browsers, won't be an issue. But you'll see a lot of these used in credential harvesting attacks. So someone that's either targeting your users directly or potentially your organization, you will see these certificates, the free ones, because it's easy for them to stand up, and it makes that little check mark show up in the browser bar, and the users will be more susceptible to it. The other one is the paid certificate. This one is, if you're seeing this and you think it's malicious, then that means there is someone behind it who really wants into your organization. And especially if it's a certificate that using the DNS twist method that Ryan talked about earlier, if you see a doppelganger or a one-off of your domain and it's a paid certificate, you know that's someone that really wants into your network, or it's someone that's got a lot of interest in you. So how can you use this for network defense? The first place to start is IDS. Anyone here use Sierra or Bro? Awesome. Snort? Okay. So with Sierra and Bro, it's quite easy. Sierra, you can do a TLS fingerprint rule, very easy to match. Bro, you just throw it into the Bro Intel framework, and it'll find it on no matter what port the TLS session is actually on. Snort, it's a little harder. You actually have to write rules to match bits of the certificate, or I believe it's the Polish CERT has actually created a package for Snort 3 that allows you just to actually drop in a fingerprint into the rule. So you're putting this into your IDS, potentially maybe your firewalls can actually do TLS monitoring. But like others, I think you should automate as much of this as possible. The first one, I'd say, if you haven't tried it out, take a look at PASSIVETOTAL. You can put in IPs, domains, malware hashes, TLS fingerprints, and you can actually get a daily or weekly update that said, hey, something's changed or we've seen this somewhere else. It's a CSV, you can pull it back down into your environment. The other one is, anyone heard of census.io? Okay, a couple people. I'll talk about them a little bit more, but as long as you get a researcher account, you can get API access. You can write a script on a daily basis to say, hey, these are the certificates or the IP addresses that I'm interested in. Do you have any data on them? Or you can use, has anyone used Scans.io or heard of Scans.io? No? Well, a couple people? All right. I'll talk about them as well. You can either pull their data or the census.io data down to a local data store and search it yourself. I actually use a combination of all three of these for my job. But the idea is you basically create a script, have it automate as much of the data collection as possible, but still have an analyst review it. A lot of this data, if you automate it to just completely blocking, you're going to probably block half the internet at some point. So I still think there needs to be a human involved at the decision layer. So I've talked about TLS certificates, I've talked about how I can use them, but where do you actually start? First, you need some data. You could scan all the internet. I've done that. It's fun, it's exciting. You freak out when you see your cores are fully maxed and you're writing a ton of data and you have no place to put it. But a lot of people can't do this on a regular basis or don't have the infrastructure or the backing to do it. Thankfully, some others have already done that for us. So I mentioned Scans.io. Scans.io is a website where a lot of people upload their research data, their scan data. The big provider of that data would be Rapid7. They have a project they call SONAR that they scan the internet on a regular interval and say, hey, they provide all the data that they actually get back and post it for the community to use, and I don't think enough people are leveraging that data. The other one's census.io and PASSIVETOTAL. So let's talk about the SONAR SSL scans. One caveat to this is it is only on TCP 443. Now they do have a non-SSL port scan. That's where they're talking about the primary SMTP ports, POP, and IMAP. But I'm only going to focus on the port 443. What's fantastic about this data is they have it going back to October of 2013. It's very easy to consume. It's in a CSV. That's in multiple CSVs, actually. They update it weekly. Typically, the updates come in on a Monday or Tuesday. The data itself is actually very incremental in nature. By that, I mean with the 3 files they provide, I only use 2 of them. The first one is the search.gz file. That one has all the new certificates they saw that week, and all it is the SHA-1 fingerprint and the raw base 64 of that certificate. Very easy to consume, very easy to script, get that data out and put it somewhere. The other one is the host.gz file. That one is just the SHA-1 and an IP. That's it. Okay, kind of cool. But the hard part with that is, let's say they scanned your website last week, and it was a new website you stood up, and your local admin hadn't changed the cert, and it's got the default cert for your OS. So you look up your IP, and you see it had that certificate. Well, you have to ingest that week's new certificate data. And then you have to, or let's say this came 6 months ago. You have to ingest the 6 month ago cert data. So in order to make this really effective, you have to import all of the data. It's easy to do, it's just time consuming. But once you have it and you just make it a weekly process, it may be 4 hours of computer time. The other thing is I'm not aware of a public search interface yet to the Scans.io data. I believe they may be working on one. And another one just to think about, is a weekly scan frequent enough? So the other data set I want to talk about is census.io. They do TLS, they do more than just TLS scanning. They do some other scanning. If you haven't checked them out, please do. But they do TLS on ports 25, 110, and 143. You can see them there. What's fantastic about Census is they use an awesome search interface. It's basically full text indexed. So if you want to look for something, you just type in the text string you're looking for, and if they have something, they'll pull that data back. They also provide API access to researchers. It's basically 2 or 3 people from the University of Michigan running it, so they can be swamped. They may take a little bit of time to respond to your emails, but if you email them and say, hey, I'm a security researcher or a threat intel analyst, chances are they will open it up to you. What's fantastic about their data is it's very frequently updated. In some cases, I've seen them update their data set 2 to 3 times a week. In other cases, they may get bogged down, they only do it once a week. That's okay. But their data is all or nothing, meaning if they scanned me last week and I searched for my data last week, I see, hey, maybe it was that snake oil certificate from Ubuntu, and I see that. And then maybe, hey, I went production, I put a purchase certificate up, and they scan me today. Well, I will only see that purchase certificate in their search interface. I won't see the historical data in their primary search interface. But what's great, if you get a researcher access or get access to the API, you can download all their old JSON. They provide the JSON files of all their scans. It's very verbose. The actual data per scan after it's decompressed is roughly 230 gigs. So if they're doing that multiple times per week, for some that could be a lot of data to ingest, or you have to figure out what data you actually want to drop. The other thing that they offer is they offer a SQL-like query interface. A lot of their data is actually being stored in a Google technology called BigQuery. And if you get researcher access, you can actually write SQL queries against their BigQuery data. So you can actually historically go back to, I think their data starts in around October of 2015. You can go back and do queries against all of their data. It just takes some time, but it is quite doable. The other tool that I want to talk about quickly is PASSIVETOTAL. Who here uses PASSIVETOTAL? Okay. I think the team over there has done a great job. It's a great place to start for any analyst. It basically gives you a lot of the data that we've talked about from the passive DNS, the Whois. They merge in TLS certificates. They also do a lot of other interesting data pivots, especially around like tracking cookies and things like that. And it's a great place for an analyst to start. And hey, everyone gets their first 25 queries for free. I will caveat this, I am a fanboy of PASSIVETOTAL. So they did not pay me to say this, but Brandon, I would really like to keep my unlimited account. So now that we've covered some of the basics, let's go ahead and get hunting. So I want to thank Scott Roberts for this. He and I were talking about this briefly, and he dropped this on me in a Slack channel. I said, hey, can I use this? He said, yeah, just give me a hat tip. So I'm going to be talking about the group that's called Fancy Bear or APT28. And the reason I like that is because, hey, it's kind of like smacking the bear a little bit. I think someone else said, yeah, but what this graphic doesn't show you, after you smack the bear then gets really pissed, rips off your head, and you're done. So let's talk about APT28, the next tunnel. Has anyone heard of this? Okay, a few people. So this has been talked about in several forums since about June of 2015. The first one was NETZPOLOTIK, a German newspaper, talked about how the German parliament had been hacked by this group, and they specifically mentioned the words XTUNNEL. And then CrowdStrike has a blog back in June of this past year called Bears in the Mist. It's about the DNC hack. They also, in the indicators section, they mentioned XTUNNEL. And then ESET, back in October, did a multi-part series called Lifting the Lid on SEDNet. And again, XTUNNEL was referenced. So let's just start with the NETZPOLOTIK report. In the report, they listed a domain, a TLS certificate, or excuse me, 2 domains, 2 IPs, and a TLS certificate. What's interesting is that first domain there, 454-reverse-crookservers.net. That's actually the host name. If you did a reverse on one of those IPs, that was the actual host name from the ISP. I kind of find it funny that the ISP calls himself crook servers. But let's take this data and let's do a traditional passive DNS pivot. So what we can see is one of the IPs that was listed in the initial report by NETZPOLOTIK had the 454 reverse crook servers and then QOV.al. Does anyone have an idea of what that could be? It's not GOV, but QOV. That's the government of Albania. So this is a suspected Russian nation-state group. They may or may not want to target Albania. And this is like a DNS twist. It's QOV, not GOV. So then if you look down further, that IP had those domains and it had all these other interesting ones. The one all the way to the right, the www.mod.qov.al, again, the Ministry of Defense for the Albanian government. The three on the left, the mailpho.com, not 100% sure on this, but there is a PHO office in, I'm going to pronounce this wrong, the Kherson region of the Ukraine, and that is some sort of legal office, and that area of the Ukraine is the territory just north of Crimea. So we've done passive, let's do a TLS certificate pivot on that initial IP. There was already one in the report, we find two more. Let's take a look at those. So the one on the left is a certificate for login.vk.com. Does anyone know what vk.com is? Yep, it's Russian's Facebook. It's kind of interesting. I'm not going to go into why we see a certificate for that on an IP address that was potentially related to the hacking of the German parliament. The other one is mailmfa.gov.ua. Looks like it's trying to mimic a mail site for the Ministry of Foreign Affairs of the government of the Ukraine. Then the one in the middle, this is the one that's going to be interesting, is this 454 reverse crook servers. Again, this is the default certificate provided by probably by this hosting provider when they created a new system. Let's take a pivot on that. This is as of 2 weeks ago. Three weeks ago, I'm sorry. So the two green nodes all the way up at the top, those were the original ones. The first one's from the original NETZPOLOTIK report. The other one is the other one we found in a passive pivot. And then there's a bunch more. Well, let's highlight the data that we get from CrowdStrike. Two IPs they listed show up in this report. And then ESET had 9 IP addresses. So we can actually say, using open source reporting over this 18, 20-month period, that we have maybe, 30, 40% of this covered at open source, but there's a lot more that wasn't. Let's look at timeline of that activity. On average, so the blue up at the top is the NETZPOLOTIK report. Anything that's brown was highlighted in ESET. Anything that was red is CrowdStrike. Everything else green is, I haven't seen anything open source about it. I may have missed a couple things. What's interesting, the longest time frame was 1 year, but typically you're only seeing it active for a couple of months. So from a network defense standpoint, if I was in an organization that was like to have been targeted by this group, you have 1 or 2 months basically to find them and get them off. Using this as a method to find them, at least monitor your defenses, I think is highly successful. So in summary, the initial reporting we had from the NETZPOLOTIK, because that's the one I started with, you had 2 domains, 2 IPs, 1 TLS certificate. Traditional TLS or passive pivot gave us 5 more interesting domains. Then once you add in TLS hunting, we have 38 IPs, 7 domains, and 3 TLS certificates. And I would say on a monthly basis, I'm seeing 2 to 3 new IPs every month, on average. So one last example. Has anyone seen TRICKBOT? Heard of TRICKBOT? Okay. So Fidelis's Threat Geek blog had a interesting post back in October. They said, hey, we saw this new malware, it looked a lot like Dire. What was awesome is in their post, they had several IP addresses that called out port 443. And the analyst to me said, what are the chances there's a TLS certificate on all those ports? So let's put all that in a nice little graph. And let's do a pivot. And sure enough, there's more than the 12 or 13 IPs that were in the Fidelis report. There's been a ton more. So from a network defense standpoint, if you're monitoring this or have the ability to monitor this, you can at least get warnings and say, hey, we're seeing some traffic that was flagged for the certificate. Previous job, I did this a ton with Dire, and it was fantastic. Great method to find it. Found it a lot faster than anything else we had. So if we overlay malicious samples, there's a ton of samples of TRICKBOT. And what you'll see in this graph is all the little bugs or malware samples, and they point back to multiple IPs, some that were in the initial Fidelis blog post and some that were not. So for me, this helps me cement that, yeah, this is a good certificate that I want to track because I'm seeing samples beacon out to multiple IPs, some that were open source reported, some that were not. So in summary with that, we have 13 IPs that were initially started. We find 22 more just doing a TLS certificate pivot. And we have a lot of malware samples that link a lot of those together. So in conclusion, I think that we should all continue to look for new ways to monitor and track infrastructure. As more and more people have talked about Whois, tracking, the attackers have gotten smarter. And they start doing things like privacy protection. And makes it a little bit harder for us to track Whois data. So we have to try to keep on their heels, if you will. In this case, more and more malware is trying to move to TLS because it's encrypted, goes through the border, looks like normal traffic. So if we can spend more time figuring out ways to track them, I think this is a great opportunity for us to actually, as defenders and intel analysts, have a huge win. The other one is I think this should be a part of your daily or normal infrastructure hunting. If you're an analyst and you spend time looking up IPs, domains, add TLS certificates, figure out a way to do it. Either use a service like Census or PASSIVETOTAL, or work with a developer, have them help you bring in the SONAR data. Once you start processing that data, it can be an uphill battle. The initial load's going to take you a while, but once you get there, there's a green pasture ahead of you, and it is fantastic. You will find a ton of data for you to search. With that, I want to thank these three gentlemen over the past 3 years as we've worked on this method. They've been great for some sounding boards and just a general research. And with that, I'll open it up to any questions. And here's my contact info if anyone wants to reach out after the conference.